Manufacturer uses a machine to make metal rods. The length of the metal rod, L, is normally distributed with mean 8 and standard deviation x. Given that the proportion of metal rods less than 7.902 centimeters in length is 2.5%, let's just write that down. Probability that L lower than 7.902 equal to 0.025. Show that x is 0.05 to 2 decimal places. By the way, if you can't do this bit, you can still then use it later on. All right. Well, to deal with this, we've got our normal distribution with mean of 8, and I'm going to transform it to the standard distribution with mean of 0. So let z equal L minus 8, because that will get the mean to 0. But then I'm also going to change the standard deviation by dividing through by x. That will give me a standard deviation of 1. So then the probability that z is lower than 7.902 minus 8 over x remains as 0.025. And we can do inverse normal and work out what x is. Okay, it's already set up because it's a less than, so 0.025, keep all that the same, minus 1.9599. I'll just rearrange, so x is going to equal 7.902 minus 8 over minus 1.9599. That becomes 0.05000 in fact, so 0.05 to 2 decimal places. Then asked to calculate the proportion of metal rods that are between 7.94 and 8.08. Okay. For this, we can just go to normal CD, put the lower as 7.94, upper is 8.09. And our calculator does an integration of the curve that describes the normal distribution in question. It's using like numerical methods. Right, let's not forget, okay, mean is 8. Oh, and standard deviation is 0.05. This gives 0.849. Now, the cost of producing a single metal rod is 20p, and the metal rod for where it's below 7.94 is sold for scrap, so lose money on those, but between 7.94 and 8.09 sold for 50p, and then when greater than 8.09 shortened for an extra cost of 10p and then sold for 40p. That means there's going to be a 40p made from that. We don't really need to consider these separately. Calculate the expected profit per 500 of the metal rods. Give your answer to the nearest pound. So if I knew that, say, 100 rods were being sold for were less than 7.94, I'd just do 100 times 5. So we need to work out the proportion that we expect to sell and then times them by the price that we're sold for. So let's do less than 7.94, probability L lower than 7.94. Okay, now I can just put my upper limit as 7.94. We get 0.1150. So then if I want to work out how much money would be made, it would be 500 times that. And then I'd also multiply by the 5p that I'm sold it for. So this bit tells me how many I'd expect to have that are less than 7.94, and then I'm just timesing by the price from it. the like how much we're selling it for. I'm gonna have to consider the amount like what we paid for them as well, but we'll come on to that. Got the probability already for it being between 7.94 and 8.09. Was 0.849, well, 0. I'm going to add an extra one there. And finally, we can look at the probability that L is greater than 8.09. If you put that in, then you get 0.03593. These will add up to 1. You can check that if you want. So we can be pretty confident that's correct. Okay, so this one here would be 500 times 0.849 times 50, and then 500 times 0.03593 times, even though it cost us 10, we're then selling for 40, so we just selling for 50, so we just times by 50. And therefore, expected profit is going to be these added together, and then I'm going to minus, I should have written this earlier, so what did it cost us? 20p, so 500 times 20 is what it's going to cost us. So we can just do 500, like factorize that out. And then I'll minus the 20. Okay, if you want to do it separately, that's absolutely fine. Each term separately. This gives us 12,231.1. Hence, it makes sense to round it to pounds. Does it say anywhere nearest pound? So £122. Nicely done. Same manufacturer makes metal hinges in large batches. They each have a probability of 0.015 of having a fault. A random sample of 200 hinges is taken from each batch, and the batch is accepted if fewer than 6 hinges are faulty. Manufacturer is aiming for 95% of the batches to be accepted. Explain whether the manufacturer is likely to achieve its aim. So we're actually back to a binomial distribution here. I'm going to say that x follows binomial distribution with 200. And probability of success, which is it having a fault, is 0.015. X is then the number having a fault. So the probability that X is okay, it's accepted if there's fewer than 6 hinges as a faulty, so X is less than or equal to 5. And we get a pretty high probability, 91.76%. But the company is aiming for 95%. This is lower. So our answer is unlikely to achieve the aim. Of course, this is just a probability, so it could be that they do, but the probability is saying it's going to be lower than what they want. Well done on this question.